This is a key to the worksheet on the relationship between the degree of a polynomial, the number of x-intercepts, or the maximum number of x-intercepts, and the maximum number of turning points. So number one, you're told that a polynomial function has degree 5. And part A and B talk about the maximum number. So it's the maximum number of x-intercepts this function can have, and then what is the maximum number of turning points this function can have. So what I would do is first of all think about a quadratic function. So let's talk about a quadratic function. So remember, a quadratic function has degree 2. A quadratic function has degree 2, right? Okay. Now, remember, the graph of a quadratic function is a parabola. So the parabola could do this. So there are no x-intercepts, right? It could do something like this, no x-intercepts. It could do this, right? So there are 2 x-intercepts. It could do this, again, 2 x-intercepts. Or it could do this right here, where it has just 1 x-intercept, correct? 1 x-intercept. So in terms of x-intercepts, what we should notice is that a quadratic function has degree 2, and notice that the maximum number of x-intercepts is 2. So I had 2 here, 0 here, 1 here, right? So the maximum number 2. So I know the relationship right away with regards to degree and x-intercepts. The maximum number of x-intercepts is always equal to the degree. That's the maximum. It doesn't say you're going to have that many, just says that's the maximum. The turning points, notice there's 1 turning point here. See that? 1 turning point. So the maximum number of turning points is always 1 less than degree. So the degree is 2. The maximum number of turning point is 1. All right. But in a quadratic function, there's always 1. You're always going to have 1 turning point. But that's not always true with all these functions. All right. But the rule is this: the maximum number of turning points is always 1 less than a degree. But we all know that a quadratic function has just 1 turning point. All of them have 1 turning point. Okay? All right. So let's answer this number 1. Number 1 is easy. So if the degree is 5, we know now that the maximum number of x-intercepts of this function, so the maximum number of x-intercepts has to be 5, right? So the maximum number of x-intercepts is always equal to the degree. So doesn't mean there's 5, it means the maximum is 5. So we have 5 all the way down to 0. Okay, you can have a polynomial function with that degree that does not have, well, the degree is 5, so the degree is odd. The degree is odd. So you're going to have, now we're going to talk about this later on, but since the degree is odd right here, since the degree is odd, you're going to have at least 1 x-intercept. I was going to say all the way down to 0, but that's not true when the degree is odd. So when the degree is odd, you have to have at least 1 x-intercept. I want you to show you why that's true. So watch. So the degree is odd. Remember, you learned in a previous lesson, if the degree is odd, the end behavior, one will go to the right and the other will go to the left, right? Even it looks like this. So at some point, notice it'll do something like this, correct? But notice the arrow keeps going down, so it's got to cross the x-axis. So you're always going to have at least 1 x-intercept because one end opens up and one end, I didn't mean open up, I mean goes up, and then one end goes down like this. So you have to have somewhere where the graph is going to cross the x-axis. So the degree is odd, but to answer the question, the degree is 5 in this case. The maximum of x-intercepts is 5. To go a little bit further, we know that since this is an odd number, you're going to have at least 1 x-intercept. You're going to have at least 1 x-intercept. Okay, what's the maximum number of turning points? The maximum number of turning points is always one less than the degree. So the maximum number of turning points is going to be 4. All right, it could be 4, 3, 2, 1, or 0. Okay, it could be 0, because remember x cubed, just to show you, x cubed is odd, right? X cubed, y equal x cubed. So remember, y equal x cubed looks like this. So y equal x cubed has no turning points. There are no turning points. Y equal x cubed. So there are functions where you're going to have no turning points. So for example, y equal x cubed, y equal x to the 5th, y equal x to the 7th, all those have no turning points. So all these power functions, see, these are power functions, right? Power functions. So all these power functions with odd exponents are going to have no turning points. No turning points. And actually it's a little bit more flatter on this end, something like this. All right, so no turning points. All right, because it's always, in this case, it's always increasing for these three right here. Increasing, and again, x to the 9th, y equal x to the 11th. None of those will have turning points. It'll look something like this. It'll get a little bit, I mean, it won't be the same function, obviously, because these exponents get larger. But it'll get flatter and flatter around this little area right here. All right, and then it'll increase rapidly, and the same thing here, as the exponent gets larger. Okay, all right, so number 2. So number 2, you have this function f of x is equal to 7x to the 8th minus 5x squared plus 8x minus 7. So in a polynomial function, notice there's only one variable, so it's easy to determine the degree. The degree will be the largest exponent. And so the maximum number of x-intercepts is going to be 8, and the maximum number of turning points will be always one less, so the maximum number of turning points is 7. Does not mean there's going to be 7. It means that the maximum number is 7. Okay, maximum number of 7. Now, just to let you know, when the degree is even, remember an even function. I don't mean to say even function. When the degree is even, the end behavior. Just remind you about the end behavior. When the degree is even, the end behavior. Remember, the arrows point in both directions, either like this or like this, right? So at some point, however it looks, at some point, it has to do this, correct? So you could have, so to go from here to here, it has to turn, doesn't it? So when the degree is even, you have to have at least one turning point. All right, you have to have at least one turning point. We saw here, when the degree is odd, it is possible to have no turning points. When the degree is odd, it is possible to have no turning points. But when the degree is even, because remember the end behaviors point in the same direction. So when the degree is even, it has to have a turning point, at least one. Now, to answer the question, you didn't have to know all about this. But that's something you're going to learn. But since the degree is even here, the maximum, since the degree is 8, the maximum number is 7. But since it's even, it can go from 7, 6, 5, 4, 3, 2, or 1. You cannot say there aren't any like you did when we talked about this one. So just keep that in mind. Some students have trouble with this one because see, this is in factored form. It's not written like this. Whenever it's written as a polynomial in standard notation like this, it's easy to determine the degree. Here, it's not that easy for some students. But all you do is just look at the leading term of each of those factors. So if you look at this first factor right here, x minus 5, the leading term is x. And you notice the degree here is 1, right? Degree is 1. If you look at this factor right here, the leading term is x squared. and knows the degree is 2. And if you look at this factor here, the leading term is x and the degree is 1. So in finding the degree, all you basically do, once you find your leading terms, is look at the exponents. 1 plus 2 plus 1 is 4. And then there was a worksheet. I don't think it was one that you had to turn in, but there was a worksheet where you had to indicate the leading term. So the leading term, if you were to multiply this out, but you would not, but if you were to multiply this out, the leading term would be x times x squared times x, which is x to the 4th. And so notice that if you were to multiply this out, the leading term would be x to the 4th, which is degree 4. All right, what's the maximum number of x-intercepts? The maximum number of x-intercepts is the maximum number is equal to the degree. And then what's the maximum number of turning points? The maximum number of turning points is always 1 less than the degree, so it'll be 3. All right, you have 3 turning points. Can the degree of a function be 7? And the answer is yes. So if the degree is 7, remember the maximum number of turning points, is always the maximum number. Notice I'm using the word maximum. Maximum of turning points is always 1 less than the degree. So the maximum of turning points is 6. So notice you can have 6, 5, 4, 3, and then 3 we have here. So can you have 3? The answer is yes. All right. And since the degree is 7, that's odd. It is possible where there are no turning points, right? Especially if you have a power function. All right. Number 5. So k of x has 10 x-intercepts. So you know it has 10. Can the degree of the function be 8? Well, remember, if the degree is 8, the maximum number of x-intercepts is 8. So the degree is 8. The maximum of x-intercepts is 8. So no, you cannot have 10. So the answer is no. All right. So that is the key to this worksheet on the relationship between degree, x-intercepts, and turning points.